Well, good morning, everybody. Today we are going to talk about functions in a little bit more detail rather than just telling you is it a function or a relation. We're actually going to be using functions today. So our notes are going to come from page 113 and 114. Your assignment is just one page long, page 117. So I've started off with a definition of a function. A function is an equation that generates an ordered pair, so x, y, by taking an input and producing an output. A pretty good depiction of this is a function machine. So here we have a function machine. Inside of it is some unknown function. We are going to put an x into the machine, and it's going to go through the function and produce an output. And then we write that output as an ordered pair, x, y, which we can plot and graph. So let's take a look at a working function machine here. So for question number 1, there is a function machine here where the function on the inside is y is equal to x plus 4. We're going to take 4 separate inputs, put them into this function. We'll work that function out and see what outputs are produced. So we will write our inputs here. They were given to us. These are the numbers that we're going to put into the machine, -5, -4, -2, and 0. And we're going to discover what outputs come out. Here's how it looks. So here is the function inside the machine. Y is equal to x plus 4. X's are our inputs. So we have -5, -4, -2, and 0. Those are the numbers I'm going to put into the machine. So I put in a -5, a -4, a -2, and a 0, and I just have to calculate what comes out when I do this. So -5 plus 4 is going to produce an output y is equal to -1. -4 plus 4, that's going to produce an output of 0. -2 plus 4, that's going to come out to an output of 2. And 0 plus 4 is going to produce an output of 4. And now we have 4 ordered pairs that if we chose to, we would be able to graph. So let's just take a look if I'm going to do that on this one. Okay, so let's go ahead and do that. And if this is actually a function, it should produce for us, in this case, a straight line. So let's go ahead and take those inputs and outputs and put them on the graph. So we have a -5, -1. So on our x-axis, we go to the left, -1, 2, 3, 4, -5, and down 1. Let's go to -4, 0, -1, 2, 3, 4, and I'm not going to go up or down. I'm going to stay 0 on the y-axis. -2 and 2, 0 and 1, 2, 3, 4. And you guys can see that if I was to connect those points, I would have produced, in this case, a straight line. This happens to be what we call a linear function. Let's go ahead and look at some other examples as well. So here we go. The next function that I chose, I went ahead and wrote it in a little simpler way, okay? So the function is going to be y is equal to 3x. This is what's inside the machine. I went ahead to save space and I wrote my t-chart and my input-output table sideways. So here are our x inputs, -2, -1, 0, and 1. And I'm going to put them into the machine and see what outputs are produced. So here we go. So first I'm going to put in a -3, then a -1, a 0, and a 1. So let's work it out and see what our outputs become. 3 times -3 is going to be a -9. So that's my first output. I don't see it. My -3, -2 is what I was supposed to put in. So let's correct that. Sorry for my mistake. Here we go. That's going to produce an output of 3 times -2 is -6. 3 times -1 is going to be -3. 3 times 0 is 0. And 3 times 1 is going to be 3. And now we have an input-output table. If we wanted to graph it, we could. Let's go ahead and do it. Let's just see what that looks like. So I got to make sure I write these on my graph correctly. So I'm going to go ahead and graph these inputs and outputs. So I'm going to go to -2, -6, -2, -1, 2, 3, 4, 5, 6. Like the last one we did, this is linear and should produce a straight line for us. -1, -3, -1, -1, 2, 3. 0, 0 is the origin, and 1, 1, 2, 3. When I connect these, you can see I've produced a straight line. This helps us just verify in this case that we actually have solved each of our inputs and outputs correctly. Let's go ahead and look at another version of these same questions. So these are actually simpler. Once again, they've given us a function on number 7, y is equal to x minus 5. We are going to put some specific inputs in there. Rather than an input-output table, they simply told us what the domain of this function is. They want us to find what the range is if our domain is 4, 6, and 8. Remember that domain is made up of x values, and then range is made up of our y values. So all we have to do is input these 3 values, 4, 6, and 8, and then we will identify what those outputs are, and we'll just make sure that they're in order from smallest to biggest when we write them in our range. 4 minus 5 is going to be -1, 6 minus 5 is going to be +1, and 8 minus 5 is going to give me a +3. Now let's go ahead and write those outputs in order from smallest to biggest, and that should be our range. So -1, 1, and 3 is my range and my final answer. Let's do it again with a slightly more complicated version. So here is our function, y is equal to x divided by 4 minus 5. They have given us a domain of -8, -4, and 12. These are our x values, our inputs. That's what I'm going to put into this function. -8, -4, +12. And let's see what our outputs are and then write them as a range in order from smallest to biggest. So -8 divided by 4 is going to give me a -2. -2 minus 5 is going to be a -7. -4 divided by +4 is going to be a -1, and -1 minus 5 is -6. Finally, 12 divided by 4 is going to give me 3, and 3 minus 5 is going to give me a -2. Let's go ahead and put them in order as a range. So we have -7, -6, and -2. So there is our range in order from smallest to biggest. And if we wanted to, we could plot those points. In this case, this would be another linear equation, but we're not going to do that in this case. I look forward to talking to you guys about this more and doing more examples in our Google Meet, but that's all there is to this assignment.